Here we are discussing compression waves, pressure variation in sound wave. Let us consider a sound propagating zone. Just I'm taking as a sound propagating zone. Sound propagating zone. Sound propagating zone is just I'm taking like it's like this is sound propagating zone. Its cross-sectional area is just I'm taking as S. The sound is propagating through this with velocity is V. Now I'm choosing in this a small region is considered. This is the region. Now let it be it's A and next one is B. So the width of this is what it's a dx. Okay, so this is at the position is what x is the position x. So every particle means what from A to B the particle is vibrating to and fro in the direction of propagation of the wave. So the speed of longitudinal wave is what v. Now here we can take periodically compression and rarefaction occurs. They occur. So where there is compression, the particle experiences high pressure. Okay, so it experiences a high pressure than of normal pressure. Where there is rarefaction, it experiences low pressure than of normal pressure. You can say like this one. So now the particle displacement is, just imagine that the particle is displaced from here to here like this. This is what some compression is occurred whenever this is, it's a dy. Okay, is the compression is occurred. Now generally the displacement of the particle is y is equals to a sine omega t minus kx. Now compression of the particle, it's a dy is equals to differentiation a k minus cos omega t minus kx. So this is what dy is equals to minus a into k cos omega t minus kx dx is my first condition. This is second condition. Okay, so this is what compression. Now what is the volume compression? Its volume is, this is volume, cross-section area is S into dy, which is equals to volume. So volume compression dv is equals to S into dy. So S is the surface area and dy is already we have written minus a k cos omega t minus kx dx. So now volume dv is equals to so S as is minus a k s and cos omega t minus kx dx. So dx into S is what? Volume, correct? So this is what? Volume. So volume dv by v is equals to minus ak cos omega t minus kx. This is called volume strain. It's a volume strain. So now I'm going to talk about, so bulk modulus B is equals to delta P by volume strain minus delta V by V. So delta P by volume strain is A K cos omega t minus kx. So we can write delta P is equals to B A K cos omega t minus kx. So we can write delta P is equals to delta P naught cos omega t minus kx. This is called pressure amplitude. Is the pressure amplitude. Delta P is called pressure equation. Pressure equation of particle. So this is the pressure equation. So finally, pressure equation is delta P is equals to delta P naught cos omega t minus kx.